Myself Arinal Patil, and today I am here presenting the seminar presentation of oblique cutting and orthogonal cutting of ISE of tool engineering. First of introduction of a metal cutting. Before learning presenting the oblique cutting and orthogonal cutting, we learn first the metal cutting. What is a metal cutting? Metal cutting is machining process in which metal is removed from the workpiece from the chip formation using the cutting tools obtain the desired shape and surface finishing. Basic elements of metal cutting: workpiece, cutting tool, relative motion, and chip formation. And objectives of metal cutting: achieve required dimension, accuracy, improve surface finish, and improve finishing. Importance in industry: used in turning, milling, and drilling operation, critical automotive, aerospace, and manufacturing industries. Types of cutting process: there are two types of cutting process: oblique cutting and orthogonal cutting. First, orthogonal cutting. In this diagram we see the chip formation and the cutting of tool cutting the workpiece. Here in orthogonal cutting we see the chip formation is a perpendicular, our tool is perpendicular to the workpiece. In oblique cutting, the chip formation is inclined and tool is also inclined to the workpiece. Here we see the chip is perpendicular, chip formation is perpendicular, and in this the chip formation is inclined. Fundamentals of orthogonal cutting. In previous slide we say the chip formation is a perpendicular, so 90 degree is a cutting velocity. It is used in 2D cutting models, and only in this there are only two forces: thrust force and the cutting force. In fundamental of oblique cutting, we see that in oblique cutting there are inclination in a chip formation. Therefore, chip flows are sideways in a chip flow angle. Here we see the inclination of the chip formation, and it is used in 3D cutting processes. And in this there are three forces: radial force, thrust force, and cutting force. Here is the comparison of cutting forces. Here parameters and oblique cutting, orthogonal cutting, and oblique cutting. In orthogonal cutting, three components. There are cutting forces. Cutting force in oblique cutting also cutting forces and thrust force. But in oblique cutting, radial force is increased. First distribution concentrated in one plane, and it is distributed in 3D due to inclination angle. Chip flow perpendicular to cutting, and it is inclined. Chip formation comparison: orthogonal cutting, oblique cutting. Chip flow perpendicular cutting produce continuous chips, and in oblique cutting, chip flow is sideways and angled to the cutting edges. Result is reduced shear stress. Oblique cutting is reduced shear stress. Effect on a surface finishing: a mild steel, moderate finish, and for oblique cutting is a good finish. Aluminum is a fair and excellent, and plastic is may tear, but in oblique cutting it is a smooth finish. Case study example. For parameters: cutting force orthogonal 200 Newton, but in oblique cutting is 950 Newton, and its surface roughness is a 3.2 mu, and in oblique it is a 1.8 mu. Tool life is 25 minutes, and for oblique is 35, and orthogonal is 25 minutes. Optimization strategies to improve performance: proper angle selections. Recommendations: high precision turning, it is used to oblique cutting process. For research analysis we use orthogonal, and for mass production we use oblique, and a simple 2D modeling we can use a 2D modeling, we use orthogonal cutting process. Conclusion: orthogonal cutting process is a simple and theoretical model. Oblique cutting, practical, efficient, and better surface finish. For oblique cutting, lower force, better chip flow, improved tool life, higher machining efficiency. Final verdict: for modern machining industries, oblique cutting is most preferred. Thank you.